So here is our EM spectrum, right? The electromagnetic spectrum. Okay, and there's a really huge range on this. So let's go through it all. Okay, so if I start on the bottom here, we have the shortest wavelength lambda to the longest wavelength lambda. Okay, correspondingly, what that means is the shortest wavelength has the largest frequency. Okay, the smallest wavelength. Did I say that right? Excuse me. The largest wavelength, the longest wavelength, has the smallest frequency. And what we can see here in terms of energy, that we're going to see this next, small lambdas, large frequencies, large energies. Okay? Big wavelengths, so large lambdas, small frequencies, small energies. So now let's take a look. Let's scan through this thing. So if we look at, let's say these approximate wavelengths, okay? So gamma ray. So that's all this is radiation. All this is electromagnetic radiation. But a gamma ray can be emitted from nuclear radiation, from nuclear decay. Okay, so these are crazy energetic. They're very dangerous for humans and biology, and they've got a really tiny wavelength, really small energy. And as I keep scanning across, next comes X-rays. X-rays have a very, very small wavelength. In fact, that's why an X-ray is able to penetrate through your skin. You know, when you get an X-ray for a broken bone or something like that. Those X-rays are so tiny, they can penetrate through your skin. However, your bones are dense enough to reflect, to scatter those X-rays back, okay? Crazy energetic X-rays, okay? So now the next one is ultraviolet, so UV, okay? And you can see UV has got about 10 to the minus 8 wavelength and pretty large frequency. And now here, this very tiny thin sliver in the grand universal scheme of things, visible light is only a tiny fraction of the electromagnetic spectrum. Just a tiny little slice, okay? And I want you to know these numbers from roughly 390 nanometers, let's call it 400 nanometers, to roughly 750 nanometers makes up visible light, okay? And so you can see it goes as Roy G. Biv, right? So I have to write that backwards. Roy G. Biv on this scale, right? So red, orange, yellow, green, blue, violet, okay? And now as we move past the visible spectrum, we get into the infrared, longer wavelengths than visible, and less energy, okay? And as we keep going and keep going, microwaves and then radio waves. And you notice radio waves are gargantuan, 10 to the 4th meters for a radio wave. 10 to the 4th meters. That's humongous. Really 10 like to the second, so like 100 meters. That's like a football field, you know, for one wavelength, okay? So I don't expect you to memorize all these numbers, but I want you to have a rough idea. The order: gamma, X-ray, UV, visible, infrared, microwave, radio. So know that rough order. And I want you to know roughly that visible light is between 400 and 750 nanometers. Okay?